You've built amazing data sets, I have to say. You may not hear the feedback from the startup community and the pharma community and the R&D community, but it's there because you've committed to open source. And so people may not all be writing papers, but they are using those tools. There's a startup in our portfolio working on idiopathic pulmonary fibrosis. The name tells you how vexing the disease is. It's idiopathic. We don't know why it happens. The IPF is named that way. And so, he was telling me that he used your cell by gene atlases to look at millions of single cells in patients with disease, without disease, try to pinpoint the fibroblasts, double click on the fibroblasts and their gene expression.
It's incredible.
And try to, use that to inform, hey, where could I go after a new drug target in this disease that's fundamentally a strange clump of idiopathic origin. So I think there's a huge group of innovators who love the tools, the visualizations, the query systems, and really the software approach that you've built to making that data incredibly accessible. So
cell by gene is like almost an accident, though.
Tell us more.
So do you want to share a little bit about cell by gene, or do you want me to start?
Well, I don't know which part you want to get into, but the cell atlas work overall, it's kind of this crazy thing that we're, here in 2025, and there's not the kind of periodic table of elements equivalent for biology, right? So that was sort of a lot of the inspiration of it was, all right, how do we both through work that we're going to do in the BioHub and through other grants, be able to pull together and standardize a format where you can have all this data. And when we were starting off, we didn't even necessarily have in mind that we were going to use that to build virtual cell models.
Yeah.
I think that's sort of just come into focus as the AI work has advanced, but that's a very exciting thing. We should definitely spend a bunch of time on the virtual cell models, but I'm not sure what you wanted to get into on the cell atlas.
Well, the single cell work was one of our first RFAs 10 years ago. We started and we were like, okay, we think this is possible. We actually funded the methodology for it to standardize how it was going to be done. So that was 10 years ago. And we seeded a few labs to start building out that data set. But we were like, there are like millions or billions of different cell types and different permutations. Like, how are we going to do this? And especially with like a burgeoning technique. And so we ended up seeding a few groups, and they started doing work. And then they told us they had a problem. There was a bottleneck in their workflow because they couldn't